Hi, welcome back to my YouTube channel. In this video, we're going to see how we should solve this integral using Feynman's technique. So Feynman's technique does say that we should introduce a parameter, arbitrary parameter in our integral, that is arc tan of tx squared over x squared dx. And then we should take the derivative of this function f of t here to remove the thing in the denominator that makes this integral unsolvable, and then solve this integral when it became solvable. Thus, the f prime of t here is going to become the integral from 0 to infinity. The d dt here is going to move, let me write it in red here. It's going to move inside the integral, and according to Leibniz formula for integration, it's going to become a partial derivative. It's going to become partial t of arc tan of tx squared divided by x squared dx. Now my f prime of t is going to be the integral from 0 to infinity of 1 over x squared times x squared if I do the chain rule, and 1 over 1 plus t squared x to the power of 4 dx. Now I'm going to cancel out these two, and my integral, my f prime of t, is going to become the integral from 0 to infinity of 1 over 1 plus t squared x to the 4 dx. So now the thing that I can do is I can multiply and divide this inside integral by half, and 2 half 0 to infinity 2 over 1 plus t squared x to the 4 dx. Now what I'm going to do also, I'm going to add and subtract tx squared plus 1 minus tx squared plus 1 divided by 1 plus t squared x to the power of 4 dx. So right now I can split my integral here. It's going to become half the integral from 0 to infinity of tx squared plus 1 divided by 1 plus t squared x to the 4 dx minus the integral from 0 to infinity of tx squared minus 1 over 1 plus t squared x to the 4 dx. And don't forget the half here. So what I can do here is, now with the f prime of t here, I can factor out the x squared here, x squared times t plus x to the negative 2 and times x squared times x to the negative 2 plus t squared x squared dx minus half 0 to infinity of x squared t minus x to the negative 2 over x squared times x to the negative 2 plus t squared x squared dx. These x squareds are going to get cancelled out. Thus my f prime of t is going to become half the integral from 0 to infinity of t plus x to the negative 2 divided by x to the negative 2 plus t squared x squared dx minus a half the integral from 0 to infinity of t minus x to the negative 2 minus this thing here. So sorry, this should be negative 2x to the negative 2. So right now what I'm going to do here again is I'm going to define p to be tx minus x to the negative 2, and I'm going to define dp to be t plus x to the negative 2 dx. And I'm sorry, it's going to be x to the negative 1. And also I'm going to define q to be tx plus x to the negative 1 my dq thus is going to be t minus x to the negative 2 dx. So I'm gonna write this integral once again. If you plug all these things in here and do use quadratic expansion for making it more simplified, you're gonna finally be left with half times the integral from negative infinity to infinity of dp divided by p squared plus 2t minus half the integral from infinity to infinity of dq over q squared minus 2t. The integral that has same bounds are going to be 0. The area is going to be 0. So thus this half times 2, the integral from 0 to infinity of dp p squared plus 2t, because it's an even function, the things here, the 2's here are going to cancel out. I can also write it as write this thing as, because I want to have it as an arctan, 1 over p squared plus root 2 t squared dp, which is if I take the integral of that, it's going to be 1 over root 2t arc tan of p over root 2t, the integral from 0 to infinity. The integral of 0 is 0. If I put 0 here, it's going to be 0. So the arctan of infinity is pi over 2 root 2t times pi over 2. Thus my f prime of t is pi over 2 times 1 over root 2t. Now if I integrate both sides of this equation here, I'm going to get f of t equals the integral of pi over 2 t to the negative half, square root 2 is going to be here as well, dt, which is pi over 2 root 2 t to the half over 2 to the negative 1. These 2 are going to go away, which is pi over root 2 t to the half. Thus my f of t is here, and plus c some constant of integration. To determine the constant of integration, I'm going to take t as and I'm going to take the limit as t approaches 0, and you can find that the constant of integration is 0 in this case. Thus my f of t here is pi over root 2 t to the half, and I want to find the f of 1 here. Thus if I put it for f of 1, it's going to be root pi over root 2. Thus I found the integral of 0 to infinity of arc tan of x squared over x squared dx to be pi over root 2. And this is a very neat result that our integral has here. So this integral was obliterated with Feynman's technique of integration, and it turned out to be a little hard, but not very hard. Hopefully you've understood it, and if not, please let me know in the comments, and please like and subscribe to my channel, and I'll see you next video.